This is for Year 12 Specialist Maths is to support Chapter 4, 4.1, the reciprocal of circular functions. 1 on cos, the reciprocal of the cosine function, is called sec. 1 on sine is cosec, and 1 on tan is cot. How could we solve equations involving reciprocal circular functions? For example, 4.1, question 4d, cosec of x equals 1 on root 2, where x goes from 0 to 2 pi. Cosec is the same as 1 on sine of x equals root 2, and if I flip both sides, the sine of x equals 1 on root 2, or root 2 on 2. X will then equal the inverse sine of root 2 on 2, and all stations to Coburg. Sine is positive in the first and the second, therefore theta and pi minus theta. And in this particular case, the sine of an angle equaling root 2 on 2, theta is pi on 4. Therefore x is going to equal pi on 4, or pi minus pi on 4, which is 3 pi on 4. How do I sketch reciprocal circular functions? For example, question 5a out of 4.1, I've got to sketch y equals the sec of x minus pi on 2 from 0 to 2 pi. Okay, so that's going to be the same as y equals 1 on the cosine of x minus pi on 2. And what does cos of x minus pi on 2 look like? Well, it would be the cosine curve, which would start at 0, 1, go to 1 at 2 pi, be there, there, and there. And that's going to look like that without this translation. That translation will move it to the right, pi on 2. So this will go to there, this will go to there, this will go to there, and this point will go to there, and that point will go to there. So we'll end up with this. And if I'm looking for this domain, it actually looks like that. What would the reciprocal of that look like? This, which is will have an asymptote here, here, and here, because that's where the curves equal 0. Therefore, 1 on 0 will be undefined. 1 will be at 1, negative 1 will be at negative 1. So we'll end up with curves that look like that. Okay, so what does the final product look like? If I'm sketching it from 0 to 2 pi, I'm going to have an asymptote at x equals 2 pi. I'm going to have an asymptote at x equals pi, and I'll have an asymptote at x equals 0. And this is going to go through there at negative 1 and there at 1. It's going to look like this. Well, that's going to be 3 pi on 2 and negative 1. That's going to be pi on 2 and 1.